our Nginx team, Jesse Goudier, Dominic Lucia, and Douglas Turner presenting on Nginx Ingress Controller for Kubernetes, and obviously that's what the lab is about. So there'll be a short discussion. What do you think, Jesse? Maybe 20 minutes? I think we're
going to try to get to the lab by the 45-minute mark, but there's only going to be a few slides, and then we're going to do some demo. So probably 20 minutes of slides, 20 minutes of demo, and then hands-on. And the reason why we do it that way is just to make sure that everyone's got a understanding of what we're trying to accomplish in the hands-on portion.
Always a good idea. So yeah, we'll it'll be roughly about 2 hours. So you guys please stick around for the lab part. And without further ado, I'll pass it over to you, Jesse.
Thanks, Ryan. Appreciate that. And my full screen's not working, so I'm going to be jumping in and out of different demos as we go through a couple slides. So this is not going to be death by PowerPoint, and we'll just kick it off now. Level set here. Within this lab, we will be focused on Nginx Ingress Controller. There's been other sessions on Nginx Controller, the visibility and control plane of Nginx instances, and that is available, and that can manage, well, these first two things on the left right now, and Ingress Controller coming in the future. We're also going to touch on App Protect, which is our web application firewall within a Kubernetes Ingress Controller space, as well as in a Docker container, all within the lab, and we'll get to that in about 40 minutes. This is, actually it's not demo architecture, it's a change in slide name, but in general, when we talk about the Kubernetes Ingress Controller, we are talking about a load balancer, proxy, whatever you want to call it, that is routing traffic from users or some device entering a environment that needs to get to its resources. And so for those not as familiar with Kubernetes, it is an orchestration tool for your workloads, specifically Docker containers in this case, where we're trying to, let's just say we've got a cloud environment and we're getting charged per hour that virtual machines are running. And clearly, there's probably times of the day where there's more demands than there are at night. Potentially, if you think about like a retail environment or Black Friday's coming up here, they're going to need a lot more compute power to handle those workloads on Black Friday than they do when everyone's sleeping on, Christmas night, whatever that is. I'm sure there's a big difference in the demand there, though. And so Kubernetes is doing a couple things. One, sees the high demands. It will create more backend workloads, which we call pods. And the thing that routes to those new pods is called an ingress controller. And so in this case, you can see we've got some layer 7 routing, where this is a common example we do here at Nginx. And I'm going to make sure you leave with how to set this all up on your own. And this example, we've got this cafe where cafe.example.com is being listened to by this load balancer. That could be a big IP, could be a cloud-based NLB from AWS, whatever it is. It's then sending all that traffic to these Nginx ingress controllers. In this case, we've got 2 for high availability. And each one of them knows about all the routes to all of the pods out there. And so when it sees a request for /coffee in a URI, it will find the coffee service and route to, let's just say, the quickest responding pod for that service. There's a bunch of different load balancing algorithms that are available. Some more sophisticated ones would be least time for the header to load for an individual pod, or it could be round robin, or it could be weighted between the instances. So all kinds of different ways to divvy that out. And so that is what we're going to be talking about, how to configure this ingress controller to meet your needs, whether that's putting a WAF policy so that you can't do SQL injection into this backend application, to be rate limiting so that we know we shouldn't be giving more than 10 requests a second from a given client. More than that is probably malicious activity, and we'll reject that with service unavailable error, whatever it is that's going to be. Okay, so that's level setting on what Kubernetes is. At F5, we are very focused on our commercial subscription, right? So there's many open source alternatives for Kubernetes Ingress controllers. The default Kubernetes.io documentation will install a Ingress controller based on Nginx open source. It is maintained by the Kubernetes community, and so it isn't something that F5 or Nginx maintains outside the fact that we obviously are the maintainers for Nginx open source project. But Nginx Plus is a commercial subscription that brings a bunch of features to the table, and we're going to focus on those mostly in this workshop today. You obviously get things like support and that comes along with a lot of other open source commercial subscriptions. But in the case of Nginx Plus, we actually add functionality and we do things differently than the open source alternative. A few of them are listed here, and there's, depending on your business requirements, really cool, easy ways to configure your Ingress controllers that if you were using the open source alternative, you'd have to do a lot more work. And a couple of those examples are things like rate limiting and the WAF. We also have a ton more performance in Nginx Plus Ingress controller. The reason for that is we're using a dynamic API to reconfigure the Ingress when things change. So there's no reloading going on. We're using native code as opposed to using dependencies on other libraries that are outside of the Nginx binaries. And so we've actually done quite a bit of load testing. We published a blog recently on the performance differences between various Ingress controllers. And it's basically just going to tell you exactly what I just did. We at Nginx very focused on performance. We've got customers that have tens of thousands, if not hundreds of thousands of concurrent connections going to their backend applications. And we want to add as little latency as possible while still giving the business logic, right? So whether that's manipulating headers, manipulating the payload, finding at least the fastest responding service, right? All those things take some processing time, but we get it done as quickly as possible. We at F5 have about 80% of the Ingress controller market. This is from 18. I don't have updated statistics, otherwise I would have put that in here. So between F5's container ingress services, the Nginx open source ingress, Nginx Plus ingress, you're looking at a company that has a lot of experience with ingress controllers to Kubernetes. And the good news is there's competition out there, so it keeps us on our toes. And we continue to add features and push the envelope on that. I mentioned earlier, there's differences between the Kubernetes Community Edition and Nginx Plus Ingress controllers. All these slides are going to be available to you after this presentation in case you want to look more deeply into this, but I'm going to move on. Kind of duplicate based on what I described earlier. So let's go to App Protect. If you missed the session, the webinar, Wednesday webinar about 2 or 3 weeks ago, I don't remember exactly which one it was. We went into the new F5 Nginx WAF based on the F5 Advanced WAF signatures. Right, so we brought a module into Nginx Plus to give that protection at the microservice level, if you will. And the same thing that can be deployed as an Nginx instance on a physical hardware could be deployed on a Docker container, could be deployed as an Ingress controller route policy. And so really designed for modern application design. And in this workshop, we're going to look at a couple different, or you actually will deploy a couple different things here. And we even have a CI/CD tool set within the UDF environment. So you'll be able to push things dynamically like you might do in a production DevOps environment. I'm not going to go into more than this on, actually, I'll give you a little more background on AppProtect, just assuming that not everyone was at the first session. But everywhere you're seeing this green shield is a place where we at F5 envision the Nginx AppProtect potentially protecting the traffic back to the application. So you can see it could be a very small microservice where we have an AppProtect WAF policy specific to that, or we could put it upstream. We'll see the Ingress controller today, or it could be at the perimeter of the data center, perimeter of the cloud. Right? So Nginx scales both very small from a 500 meg Docker container, including all of the Linux operating system that goes with that, to an 88 core Dell server if you're running physical machines on your network. This one can probably handle a couple 100,000 concurrent connections, and this one can probably handle less. All depends on the resources that you allocate to the Nginx process. With that, though, you get a lot of flexibility, and so you put these these AppProtect containers where it makes most sense for the application. If you've got disparate application teams that don't talk to each other, forcing them to use the same WAF at the perimeter may be a challenge. So being able to give them their own WAF at the application team level potentially can solve a lot of problems. And the great thing about DevOps and Docker in general is that you could have a developer coding on their laptop at home on Docker, and then they can port that 100% to whatever you use in production. And because Nginx is so small, you don't need 10 gig of memory and 8 vCPUs in order to run this and get good performance. So when you're looking at shifting left and introducing your WAF policy to the developer prior to or during the code writing cycles, this allows you to do that, as opposed to potentially having to distribute big IPs to everyone so they can test in the development environments. What you're seeing right now is, we're very DevOps friendly with everything we do here at Nginx. Down here on the left is a sample WAF policy where we're saying if you see these unallowed follow types, we're going to delete the request, right? And there's both the ability to block requests as well as to just log them and allow it through, so you can learn what your application's doing in production. And then when you create your WAF policy, you don't introduce a bunch of false positives based on things that were necessary for that application to run. Once again, with the performance, we at Nginx have had a relationship or partnership with ModSec for quite some time now and still do. But when we were acquired by F5, we had a great opportunity to create something that was, let's just say, faster. Right? This is what we're looking at right now. Potentially more feature rich as well, if you're looking at it that way. But from the performance perspective, unprotected apps clearly have better throughput, more requests per second. Both of these things can be handled by scale. You can just add more Nginx instances to the pool, and we'll get more throughput and requests per second through them. When it comes to latency, though, adding more scale doesn't do anything for you, right? This is time that the packets took to process in order to see if they were allowed or not. And with AppProtect, we're basically as fast as an unprotected application, which is amazing. Where things couldn't be protected before, now we can. Whether or not you're, the most strict policy or the lightest policy, this is using our default. So there will be some variables within that, but our goals when we brought this out were to be incredibly fast. Okay, so that's a little background into the solutions we're going to be looking at today. Let's jump into a demo. And by the way, I put in a bunch of links to the tools that will be showing off. And if you during this demo, some of them are used within the lab, others are not. But either way, there are a lot of resources that I use on a daily basis. So let's talk about what it is to deploy a Kubernetes Ingress Controller. And to do that, in general, if you're using an open source solution, you would simply call or add a Kubernetes manifest file that said which one you're going to use. With Nginx Plus, we have this commercial subscription. And so we need to build an image and push it to a private registry for Docker containers before we are able to use it. To do that, we go to docs.nginx.com. I hope this text is big enough for everyone. If not, please let me know. And click on Kubernetes Ingress Controller. In here, we have both the overview and the installation instructions for a couple different environments, whether you're using OpenShift or using manifests or Helm, right? All different ways to deploy your Nginx Ingress Controller. You can see here, the big change with Nginx Plus versus open source is that we use this make script to build that Kubernetes Ingress Controller. Now, this tends to be where people get hung up, and when they deploy their Plus Ingress Controller, you'll get an image pull failure. And it'll usually be because you push it to a private registry and you didn't tell Kubernetes what the credentials to that registry were. That is not in the lab today, but if you go back to my PowerPoint presentation, absolutely all the instructions to get that done are in here. So part of that build is putting your certificates for our repo into this directory, which is on GitHub. Let me go to GitHub right now so you can see this documentation, because this is something you'll get very used to if you get into Nginx Ingress controllers. And so this is the Nginx Inc. Repository on GitHub. And the number one thing we have here is the Kubernetes Ingress, which has thousands of polls, lots of stars, stuff like that. Down here we have the documentation, which isn't as nice as what I showed you earlier. A couple of things I'd point out is that these subfolders have a lot of good documentation in them. The first one being this examples. Will show you samples of how to do certain things. You can combine this. And as we continue to introduce new features, you can see we're keeping this up to date. A big one that we're using today is the app protect example. And so if I go down to this, oh my gosh, let me try to back up here. So we have this ingress policy that we are telling Kubernetes where to route the requests that are coming in. And so in the coffee and tea example, we have this host that's protected by, or it's encrypted, right? So we have TLS certificates for it. And when we see requests for /t URI, we're going to pass that request to the T service. Up here at the top, we have what's called annotations, and those are what tells the Nginx instance that is that Ingress controller what additional things to enforce for policy. In this case, we're enabling app protect, and you can see that one of the policies we're enforcing is data guard. So if you're familiar with a 5 data guard, that is blocking US social security numbers and credit card information from being transmitted. And so just giving you a basic example right here, you can see we're also sending all the logs to a syslog target, and that is obviously configurable. So we have tools built in for monitoring stuff like this in terms of Nginx controller, but we don't force you to use that either. Right, so if you already have a syslog target with Splunk, Datadog, whatever it is, you can target those instances. We're not trying to replace them whatsoever. So that's an example of a Kubernetes ingress policy, and specifically for enabling app protect. Let's go to a live environment. And so when you do live environment demos for Kubernetes, you are in the terminal, right? And so the main tool for configuring Kubernetes is kubectl, which anyone that uses it long enough will absolutely give an alias to, because typing 7 characters is far too much for me. So I always alias kubectl to k, which you see commonly done on the internet. So I misspelled alias, but you get the idea. I've already done that. All right, so one thing we're going to do right now is just run a couple requests to that cafe application. And let's see, so you can see cafe.example.com. And if you were noticing earlier, and actually I've flown this cafe ingress here, there's no path for just slash, right? We've got coffee and we've got tea, but we don't have slash. So when I do a request for cafe.example.com, I get a 404. There's no resource that's going to respond to that request. And so this will only work if I go to /t. You can see the server name that responded to this request, or I can do /coffee. And again, server name changes and the request is successful. Cool thing with Nginx Plus is we give you a dashboard into your environment. This is a real-time dashboard. It's currently updating every second. I'll just change that to 3, slow it down a little bit. And you can see we've got actually a warning here. We'll dig into that. But all this will update every second. We're just targeting the API of the Nginx Ingress Controller. This is a one-off, right? So for each Ingress Controller, you'd be able to go to this dashboard. And let's go into what is this error? What is it seeing? So you can see in the responses here, we've got some 400 errors, which we caused by requesting that /URI that doesn't exist anywhere else. Now we'll get rid of this yellow by just doing a bunch more requests for something that exists. And actually, I typically just do some sort of load gen, which I mentioned earlier is in that work too. Load testing tool. And in this case, I'm going to do a request to HTTPS cafe.example.com. And we'll make sure we get /t so we get a non-400 error. So this is going to generate a lot of load, which is nice for our charts. And you can see right away all the requests per second for this cafe.example.com ramping up. That's cool. Let's look at this rate limiting down here. So this is actually a new feature to the Nginx Plus dashboard. If you haven't seen it before and you're familiar with Nginx Plus, you can see right now, no requests hitting it. So let's do that. And I'm going to try to move my screen over so we can see that chart. I know what to do. This on the left, and that on the right. All right. So back to our rate limit example. And let me show you how we did that with policy. Again, we're going to look at a configuration file. So hopefully everyone likes reading through my work here. By the way, I'll share this entire example with anyone that requests it. I will say that it is not heavily documented, so it'd be something that only share if you're really willing to read through all of this configuration and try to apply it on your own. Okay, so Our rate limit policy is in this YAML file right here. And you can see that we're only going to allow one request a second. And if there's more than one request a second, we're going to give them a 503 error code. And let's do that. And it's a different application, by the way. So I applied this to the nginx info.example.com URL. So I'll just, you can see first request worked. We're using this Nginx info application. If I do another request, it will work. If I do them really quickly, you can see I just got a 503 error. So let's do even more than that, because that's just not very fun. We want to make this chart look cool. So we're gonna now HTTP start sending a bunch of traffic, right? So we got 2 threads and 100 concurrent connections all going through there for the next 30 seconds. And I'll make this bigger. You can see that this is running. And I hope, there we go. So we got a bunch of blocks on our chart. Thank you, demo gods. And you can see the requests ramping up. We got these 500 errors showing up. Really cool stuff. Okay, so like I said earlier, this is our dashboard into a single Ingress controller, which is really good for the developers when they're developing to see what's going on with their application. But we want to aggregate this somewhere. And what we at Nginx, I mean, there's lots of examples or lots of ways to do this, but primary example I like to do is with Grafana and Prometheus. So if you're not familiar, Prometheus is a time series database. We provide what's called a Prometheus exporter for the Nginx Ingress controller. Let me see if I can pull that exporter up right now. I think it's on 9090. It is. Okay, so this is Prometheus. All it does is scrape that target that's listed here every 15 seconds in my case, right? That's all configurable within Prometheus. Actually, this is the Nginx plus Ingress right here. This is just a Prometheus Docker container, if you will. So when I click on the Nginx metrics, we just get this big text file with all kinds of performance metrics that Prometheus will then parse into its database and allow something else to do some graphing of. That something else in our example here is a Grafana dashboard. And this is also in our GitHub repository. I'll show you right now, actually. And so if you go to the root here, down to Grafana, all I did was import this dashboard right there. And you can see the picture right there. It looks very similar to what I'm doing right now. So back here, now that we've generated some load, you can see some traffic going through here. This is with our load gen. Before I started that, there wasn't much going on. And you can customize this, and you can use Grafana to alert based on, whatever metrics you think are within range or not. You can do that with other tools. I'm not telling you should use Grafana or not. Go ahead and use Datadog if that's what you've got, or anything else. But this is freely available. So within your labs, and lots of usage of this in the Kubernetes world, if you will, or a DevOps tool space world, if you will. Okay, let me see what else I got from my demos. Scaling, let's just show an example of how to do that. Let's just say, this application's not performing. We need more resources to run it. To do that, you know what? I'm going to show you the Kubernetes dashboard way to do that, which is probably not how many would do this in a production environment, but really easy tool for, as you're building your application. So this is the Kubernetes dashboard from the Kubernetes.io documentation. It is the latest version. You can see we're in a default namespace. I've got my application, or excuse me, my deployments and my pods listed here. You can see we'll target this T service down here. As you can see, we only have one right now. And so let's actually there's one up here. So let's make that 6 just to make it real obvious. So we can scale that by scaling the deployment and hitting this pencil. Scroll down, find where it says replicas, and there's 2 like we saw earlier. Let's just make it 8, and go back to the Nginx dashboard so we can see it adding more. It's already done. Oh, let's scale it down. So you can see we got a whole bunch of these cafe resources that Nginx is now tracking. Here's the first 2 that were running earlier when we ran that load test. I'm going to scale it back down, hopefully get back there while it's taking things out of the pool, if you will. I would do that gracefully, by the way. We'll just go down to 1. So when I say gracefully, we allow, what's that? And so we got 1 coffee and 1 tea. That's what these are, okay? We allow existing connections to those back-end pods to continue processing before we take them out of the pool. So there's no 500 errors that were generated to those users. Everyone continued to work or use their web application, and then as they disconnected, Kubernetes took them out of the pool. And now we'll go back to the main dashboard there. All right. There is a Kubernetes dashboard within the UDF environment. And actually what I'm going to go into now is the specific lab that we're all going to work through. So you should have got an email from our UDF system earlier. When you do, you'll come to a page that looks like this. We'll show you a demo of the whole system in a minute. Right now, the focus is to understand what we're going to be accomplishing within UDF. To do that, I'm going to show you the documentation first. And we've got pretty robust documentation. We've done this a number of times. Very clear explaining what the goals are and how this all works. We've done it a lab with F5 before. You may have seen this Acme Financial application. We're reusing that for this particular workshop, where we've got this microservices Kubernetes application that we're deploying. You'll be doing a kubectl command to deploy each one of these services. And you can see they're color coded, right? So different areas of this application, different microservices. And because they're different URIs, we can apply different WAF policies to each one of them. So you can think about, it'd be great if we just had one big strict WAF policy for the entire application. It's clear to financial services. And so we want to prevent all kinds of bad traffic from hitting it. The downside with that sort of policy is that you could be creating false positives, things that the developers intend to use in order to provide that application to the end users could be blocked by a very strict policy. And so with the ability to have more fine-grained policies here, we can say, when we're sending money and adding credit cards to the system, we've got a strict WAF policy, and where we're just viewing stock performance, maybe it's a less strict WAF policy, just so that we're processing things as quickly as we can, as well as not introducing more false positives that the developers have to work around. So that's the basics of the application we're going to be working with. I will say class 1, if you look here in the documentation, which by the way, this whole, all the documentation is publicly available if you copy the URL. Class 1, simply just walking you through what the application looks like. When you get to class 2 is when we're going to start running commands. So you can see we're going to follow these instructions to log into this Docker virtual machine. I'll show you what that looks like right now. So if I go to UDF, when you log in, and don't worry about that quite yet, you'll see a system that looks a lot like this. And on the right are all the virtual machines that have been allocated to you. One of them being that Docker virtual machine that we were going to use web shell use. Now you can use SSH. That said, you'd have to configure your public keys so that you can pass through into our system without having to log in. Not everyone is familiar with public key authentication, so that's why I recommend just using this web shell method. So that looks like this. And so I'm going to make the screen a little bigger. You can see we're logged in as root, the root folder, and all of the commands are actually going to be run as Ubuntu from the Ubuntu home directory. We will leave on the screen the modifications to the lab guide. If this is the way you choose to do it, which I recommend. If you do upload your public keys, then you won't need to do this extra step of changing users or changing directories. Once we're there, oops, I'm going to show you there's a bunch of files in this directory, and this is a Docker host, so we have a few things running already. The first time you run things, it may take a second to load, as you're seeing right now, but it will run. All right, so there you go. Right now, we are not running that protect image, and the first step will be to deploy that Docker image running on port 80. Most of the lab, you'll be working from a Windows jump host. If you can't connect to any part of this, it would be because your VPN is potentially blocking it. I've already logged into my jump host, which is down here. And you would just click on one of these resolutions and to access it. Right now, what I'm going to show you, though, is that I've already deployed that application, the Arcadia application, to the Kubernetes cluster. And so we have bookmarks to various targets within the lab. In general, if you know we're hitting the ingress directly, you can see this ephemeral port in order to access the application. As soon as you were to protect this ingress with what we're going to do, let's just say it was a big IP or with a Docker image running apt protect, you can see the URLs changed, right? So different hosts are going to be used, and we're not going to, block. The policy would be only allow requests from this upstream Docker container. That's not part of this. So you can see when we log in here, we see the application. I'm gonna pass a generic script here, and you can see that it doesn't block it. And so as you go through and build this environment, that Docker container will have the apt protect policies built into it. And if you do the same request here, it will give you a rejection message and a support ID. One of the next steps will be actually to see a visualization of what's going through these instances. And we are using a tool called Grafana for that. Let me just start a new one. Yours will look like this. Take a second to spin up. And initially, you will not see this tree view on the left. I think it's helpful. You're big enough resolution. Click this button on the bottom, expand it. Locked, so it will stick there. First thing we do is just go into a generic or a dashboard that we provided. These are all publicly available on our GitHub site. And you can see when we just hit the site earlier, just now, that request has been logged. If I do the last, let's just say 75 minutes, you can see a few more requests have gone through and some that were blocked, right? So there's our latest one that was blocked. Here's some tests that I did earlier. We want to find out, well, what was blocked. This allows us to dig into those logs and see what policy was triggered. So I think we'll just go down to this one. So you can see I got that support ID that was potentially reported back to the user, depending on your error pages that you're displaying back to users. You take that ID and then you can go into it and see, okay, it was rejected, I see that. And in this case, it was cross-site scripting, and that triggered the rule, and we blocked it. So if this was a false positive, you would just, remove this signature from your policy, and that traffic would go through happily. Let's see. Another step in the lab will be to deploy the same Docker container using a Jenkins pipeline. And so our source code is being stored within GitLab, which this is logged in as administrator right now. The particular example we go into is to add a tag to this repository that will then trigger a webhook to kick off the Jenkins job to push out that new Docker container with the latest definitions from F5 applied to it. One thing that I don't know is super clear in the directions is that in the first few steps, you're going to be building these Docker containers manually. And before you push it out through this GitLab tag, you'll want to stop your Ingress, or excuse me, your Docker container from running so that when this pushes it, there's no port conflicts and it might fail. There's a lot of this lab that you can skip in the interest of time. So if you see that you're doing something similar that you already understand, then potentially just skip that step and move on. I will highly recommend you get to the last lab in the documentation, even if you do skip a few things, and that is to deploy a new Ingress controller for this Kubernetes environment. So the first Ingress controller that's deployed does not have app protect enabled on it. And then when you get to step 8 here, excuse me, class 4 here, a new version of the Nginx Ingress controller, it will then apply that Ingress controller with these WAF policies that was shown earlier. We're actually using almost identical ones to what was in that GitHub repo. And that's it. Okay, so this, if you go through beginning to end following each step, probably will take you a little over an hour. If you go quickly, maybe 2.5 hours if some of the tools are new to you. We will be around for another hour and 12 minutes if there's any questions. And so at this point, I'm going to actually turn it over to my colleague Dominic so you can see what the experience is from the UDF perspective when you're logging in as someone who's an F5 employee, because what I showed you is slightly different than that. Is that good? You ready for that, Dominic?
Yeah, I mean, I think you covered most of it. I don't think there's much left, and these guys are already in. We've got a couple of people in the UDF system already, but let me just go back over it real quick. Okay.
You might want to zoom in. There you go. There you go.
Yeah. Okay, so when you first log in, I think we might be waiting on just one person to log in, but when you first log in, the best thing to do, like Jesse mentioned, is to open this, which is a publicly available link. You open that in a new tab. And either put that on a different monitor, or if you have Windows, you can snap it to one side of the screen or the other. I like to call this the hardest part of the whole lab, is just realizing that the way to get into the actual lab resources is in this little button right here. This is actually a different tab, and it's not super obvious that that's the case. But if you go and click on deployment and then move over here to the Windows jump host, the Windows jump host is going to be where you do most of your work from. When it says something like, let's see. So when it says SSH or web SSH to CI/CD server. So if you're looking at your own window, go ahead and switch back over to my shared screen real quick. So where it says SSH to CI/CD server, what you're going to do is you're going to go over here and you're going to look for CI/CD server. There is a way to upload your own SSH keys. I really wouldn't recommend it. It's much easier to just go in here and click on web shell. And then you'll be able to pop into here. So I think, Jesse, I can't remember if it was this lab or a different lab where running this as root versus running it as the Ubuntu user actually can screw you up. Let's just go ahead.
On all usernames, but you have to
Okay.
be in the directory Dominic's going to find
Yep.
the file.
Yep. So, okay. So you don't have to worry about sudoing to any other name, but even though you have, this is really confusing. It was confusing for me, especially because I was kind of new to Kubernetes. But again, if you're looking at my screen, I'm indicating this command. You do have to be in the Ubuntu directory. So even though this specifies an absolute directory here to this file, this is obviously a global address all the way from /. You have to, I guess, physically be inside of this directory for this to actually work. Otherwise, it'll throw some strange errors. So that's going to be the first step that you're going to do. And then the second step is going into this jump host. So on the documentation, it says go into the jump host with username and password user. So if I click again on access, one other thing, sometimes people think that this button is for the GitLab. So it's, for the one above, it's closer to this one below. I know there's this line here, but it's supposed to indicate Windows jump host, click here to access. So the way that you access this is RDP. I'm going to go ahead and use a resolution that I know is a little smaller than this monitor. If you note down here, it actually just popped up a little download. So I'm going to click on that download. It's going to try to log in as administrator, and we actually don't want to do that. If you go back here and look at the lab guide, notice that it says user. So username and password is user and user. Now, if you're on Windows, your login window won't look like this. What you'll have to do is actually click on a little piece of text that says more choices in order to go in and change the user. It won't let you change the user from administrator to user until you click that little more choices icon or link. Then it'll open it up. It'll allow you to log in with username user and password user. Hit continue, and then you should be into the jump host. So these are lab VMs. They're not the absolute fastest Amazon VMs. So definitely give it a moment to boot up and everything. The lab will walk you through bit by bit every single thing that you need to click on. So if you notice here, it says open Chrome and then the Kubernetes dashboard bookmark. So again, apps launch a little bit slowly because it's not the fastest one here. These are all self-signed certificates. And again, it's going to tell you every single thing that you need to click on. So click skip on the logon page. Cool, skip. And this is what it should look like before you run this command. And then I'm going to go ahead and run this first command here. On Windows, this is Control-Shift-V. On Mac, you can just do Command-V to paste. And there we go. The magic of Kubernetes. Those are really the only two things you need to know for, as far as a general high level interacting with the lab. The thing that I will say about this documentation, there are a few times where I think I believe in class 2, it might be in step 2 or class 2, but if you feel like you're stuck, go ahead and read the instructions for the next page, and it might get you unstuck. There's some bits of the documentation that seem to be just a little bit out of order. So if you're stuck, obviously hit one of us up for help whenever you need it. But if you're one of those types of people that likes to resolve things themselves, then feel free to go to the next step and see if the documentation is just a touch out of order there.